Let's say a ball is thrown and follows the parabolic path that is shown in this picture. Air friction is negligible. Point Q is the highest point on the path. Points P and R are the same height above the ground. We want to answer these questions. We want to find out what are the speeds of the ball at the 3 points P, Q, and R, and we want to find out what is the direction of the acceleration of the ball at point P. To answer these questions, think about a time you have thrown a ball up. What happens? The ball starts with some speed from our force, and then the speed gradually decreases and decreases until at some point in the air, at the highest point, the ball briefly stops, and then it comes back down. This is because of gravity pulling the ball back down to the ground. So using our real life experience, we know that the ball at the highest point, or point Q, should have the smallest velocity. As mentioned earlier, the air friction is negligible. So in the absence of any other forces, the velocity of the ball at the same point in the air going up is equal to the velocity in that position coming down, but just in the opposite direction. So the velocity of the ball, let's say at this point, is equal to this point, at this point is equal to this point, and at this point is equal to this point. So from here, we find out that the speed at point P is equal to the speed at point R. So going back to our question, how do we compare the speed or the velocity of the ball at the 3 points P, Q, and R? We say V of Q is the smallest, and V of P is equal to the V of R. Now going to our second question, what is the direction of the acceleration of the ball at point P? When asked the direction of an object's acceleration, it helps to think about the direction of the force on that object, because we know that we have this formula, F is equal m times a, or force is equal mass times acceleration, and mass is always a positive value. So the direction of the acceleration is the same as the direction of the total force on the object. So thinking about the direction of the force of the ball on the ball in this question, we know that there is no air friction. There is no force of air friction on the ball. So the only force on the ball is the gravitational force. And we know that the gravitational force always points down. So gravitational force here, the gravitational force here on the ball, here, it always points down. So from here we find out that the acceleration or the gravitational force at point P on the ball is pointing down. So this is the direction of the force at point P, and this is the direction of the acceleration at point P and any other point on the ball's path.